Again to Cambridge Advanced Level Mathematics. Here in this video, we want to discuss a problem on differential equations. This is a first order differential equation I took from Maths 3 of paper 3, 2022. And it reads as follows. I put it up on the board there. The variables x and y satisfy the differential equation. The y dx is equal to xy divided by y1 plus x squared. Let me read it again. The y dx is equal to xy divided by 1 plus x squared when x is equal to 0 and y is equal to 2. These are called initial value conditions, initial conditions. Now the question says solve the differential equation. Of course, as we can all see, this is a first order differential equation, and we can check if we look carefully there, it's possible to separate the variables. In other words, to put our x's and dx's on one side and to put our y's and the dy's on the other side. It's a type of equation which is called separable. So I'm looking for my pen. It's in my pocket. I found it. All right. So I'm going to write this equation over here. I hope this is a clearer part of the board than the other side there. So let's write it here and say dy dx is equal to xy divided by 1 plus x squared. Right. So we want to separate the variables here. First of all, step by step, let's take dx to that side. So this will result in, this means implies, dy, we leave dy on its own here. On this side, we've taken dx to that side. It becomes x, y, dx, all divided by 1 plus x squared. Right? What shall we do next? Let's take our y this side, divide both sides by y. That will result in dy over y. Remember, we are dividing both sides by y. Will now give us x dx over 1 plus x squared. We have managed to separate the variables now, but let's go step by step through what we have done. First of all, we have the differential equation in its original form like that. Then we took dx to this side. We got here. We divided both sides by y. We got here. And now our x's and dx's are on one side, and our y's and dy's are on the other side. Our next step now is to integrate both sides. We are going to integrate this side here with respect to y. We integrate this side with respect to y, and we are going to integrate this side with respect to x. So let's proceed and see what happens. So now we have the integral of y, 1 over y, with respect to y will be equal to the integral of x over 1 plus x squared with respect to x. Okay? Now, this part here, you can integrate it directly. You know this is ln y, but I could have written down the integral here, but I just want to show you step by step how you would get to where we want to get to. So let's write here ln y for this left-hand side is equal to, we don't know what it is. So I will divide, let me divide the board into these two parts, and I'll perform my calculations for this integral in this little corner down here. So I will say, let us suppose u is equal to 1 plus x squared. The aim here is to change the variable to u so that I'm going to integrate with respect to du. So if u is equal to this, what is du dx? Du dx is equal to 2x, obviously. So now, if du dx is equal to 2x, what is dx? Okay, take dx to this side and 2 to this side. We are left with du divided by 2x is equal to dx. Let me repeat what we did here. We took dx to this side, divided both sides by 2x, and I'm left with du divided by 2x is equal to dx. Now I have completed the change of variable. I can replace my dx here with this du over 2x. So let's do that here. This then becomes x over 1 plus x squared. Remember, we said it's u, so this becomes u, multiplied by, sorry, not multiplied, with respect to dx, but dx is du over 2x. Okay, so when you check this out, this cancels with this x, and we can take the 1 over 2, this 2 here, outside the integral, and that becomes half of the integral of du over u. And that is just half ln u. But what is u? Maybe I'm going a little bit too fast. What happened here? I replaced my dx with du over 2x. And then this, of course, becomes a u. So I've got an x here and an x down here. They cancel each other out. And I'm left with these two, which I took out. And it's a half outside the integral sign. It's allowed to take a constant out of the integral sign, but you can't take a variable outside the integral sign. So we did that. That becomes half of du over u, which of course is ln u. Now we know that u is equal to 1 plus x squared. So this becomes half of half of ln 1 plus x squared in brackets. I hope this is clear from where you are. Okay, so this is now our integral. Remember, on the left-hand side, we had dealt with y. We found it was ln y. And what we were busy trying to sort out was this guy here. And we sorted it out. It's now equal to half ln, not lin, sorry. Ln 1 plus x squared. We need a constant of integration, of course. We don't have to put a constant here and another constant here, because a constant plus a constant is a constant multiplied by a constant is just a constant. So we can do with one constant. Let's call that constant ln a. Now, let's use the laws of logarithms here. This means ln 1 plus x to the power half when we take the half to that side. And this, let's first of all do that. Let's not rush. This becomes ln 1 plus x squared to the power half plus, of course, our ln a. Again, laws of logarithms. These two logarithms are adding together, so we just multiply. This then becomes, remember when it says log of a plus log of b is equal to log of ab. Log of a minus log of b is equal to log of a divided by the laws of logarithm. That's what we're doing here. So this multiplies and it becomes ln a brackets 1 plus x squared to the power a half. Okay, again, this is all equal to ln y. Now, when two logs are, when you have got this kind of thing where it's like ln a is equal to ln b, or ln a is ln f is equal to ln d, that means f is equal to d. So ln y is equal to ln this. That simply means y itself is equal to a brackets 1 plus x squared to the power a half. I'm running out of space down here. So I've got to get rid of some things. Who shall we get rid of? Let's get rid of these guys. Okay, so we get rid of this. And okay, so we are here now. Let's rewrite our equation as y is equal to a brackets 1 plus x squared to the power half. Now we need to go to the initial conditions because we need to find the constant of integration a here. We are told x is equal to 0 when y is equal to 2 when x is equal to 0. So let's substitute. So we have 2 is equal to a multiplied by 1 plus 0 all raised to the power a half. Of course, 1 to the power a half is just 1. So that means that this implies that a is equal to 2. So therefore, y is equal to 2 bracket 1 plus x squared all raised to the power a half. This is y as a function of x. When I checked, the question was worth 7 marks, and given how long we took to blast this thing, I think it's a fair amount of mark for the effort that we applied. I wish to make it so that in our next video we can proceed and look for something that has to do with second order differential equations, dy, d2y dx squared is equal to something. Until then, bye-bye and have a good time. Thank you.